Welcome to Telangana Board of Intermediate Education. The Telangana Board of Intermediate Education, in collaboration with the Diksha portal, presents a digital education initiative to provide quality learning resources to the student and teaching community in Telangana. Now I am going to explain the intermediate first year chemistry topic, group 14 elements, subtopic allotropes of carbon. This is M.VENKATESHWARLU, PGT in chemistry, TG Model School Junior College, Peddapuram, Nampalli Mandal, Nalgonda District, Telangana State. Here some learning objectives are there. After watching this video, students will be able to understand the allotropes of carbon, define the term allotropy as it relates to carbon's ability to exist in multiple physical forms. Identify the three main crystalline allotropes. Describe the bonding patterns, specifically the difference between sp3 diamond and sp2 graphite hybridization. Explain why diamond is the hardest natural substance while graphite is soft and slippery. Discuss the unique geometry of Buckminster-Fuller C60 and its potential in nanotechnology. Differentiate between natural and crystalline forms and amorphous carbon like coal and charcoal. Relate the presence of delocalized electrons in graphite to its ability to conduct electricity. Carbon exhibits many allotropic forms, both crystalline as well as amorphous. Diamond and graphite are two well-known crystalline forms of carbon. In 1985, the third form of carbon, known as fullerenes, was discovered by H. W. Croto, E. Smalley and R. F. Curl. For this discovery, they were awarded the Nobel Prize in 1990. Now let us start allotropes of carbon. So first allotrope form of carbon is diamond. It is a crystalline form of carbon. So first one is diamond. So it has the structure. So this is the structure of diamond, and here you can see the carbon atoms. These are carbon atoms, and if you look at this point, if you take this carbon attached with 4 other carbon atoms in tetrahedral manner. So this is the tetrahedral structure, tetrahedral geometry. Now you can understand it. So this is the tetrahedral geometry. So if you take any carbon, it shows tetrahedral geometry. So see here, one, this carbon to this carbon, and this carbon to this carbon. So total 4 carbon atoms in tetrahedral geometry. It is very difficult to break extended covalent bonding, and therefore diamond is a hardest substance on the earth. It is used as abrasive for sharpening hard tools, in making dyes, and in the manufacture of tungsten filaments for electric bulbs. Next allotropic form of carbon is graphite. So this is the layered structure. So graphite has layered structure, 6-membered layered structure. So the carbon distance between the two carbon atoms here 141.5 picometers, and the distance between the two layers is 340 picometers. Graphite has a layered structure. Layers are held by van der Waals forces, and distance between two layers is 340 picometers. Each layer is composed of planar hexagonal rings of carbon atoms. Carbon-carbon bond length within the layer is 141. Each carbon atom in hexagonal ring undergoes sp2 hybridization. Hybridization and makes 3 sigma bonds with the 3 neighboring carbon atoms. Fourth electron forms a pi bond. The electrons are delocalized over the whole sheet. Electrons are mobile, and therefore graphite conducts electricity along the sheet. Graphite cleaves easily between the layers, and therefore it is very soft and slippery. For this reason, graphite is used as dry lubricant in machines running at high temperature where oil cannot be used as a lubricant. The next allotropic form of carbon is fullerenes. So this is the structure of fullerene. So here 5-membered ring and other 6-membered ring. So there are 2 types of rings are present in fullerenes. Are made by the heating of graphite in an electric arc in the presence of inert gases such as helium or argon. The sooty material formed by condensation of vaporized carbon small molecules consists of mainly C60 with smaller quantity of C70 and traces of fullerenes consisting of even number of carbon atoms up to 350. Fullerenes are the only pure form of carbon because they have smooth structure without having dangling bonds. Here dangling bonds means an unsatisfied valency on an immobilized atom that possesses unpaired electrons, rendering them highly reactive. So there are no dangling bonds in fullerene. Fullerenes are cage-like molecules. C60 molecule has a shape like soccer ball. Fullerene contains 26 membered rings and 12 5-membered rings. It is most important to remember a 6-membered ring is fused with 6 or 5-membered rings, but a 5-membered ring can only fuse with 6-membered rings only. All the carbon atoms are equal and they undergo sp2 hybridization. Each carbon atom forms 3 sigma bonds with other 3 carbon atoms. The remaining electron at each carbon is delocalized in molecular orbitals, which in turn give aromatic character to molecule. This ball-shaped molecule has 60 vertices. Here vertices means the corners or points where two or more edges, lines or curves meet in two-dimensional or three-dimensional shapes. So that is called vertices, and each one is occupied by one carbon atom, and it also contains both single and double bonds with carbon-carbon distances of 143.5 picometers and 138.3 picometers respectively. Here 1 angstrom equal to 100 picometers. Spherical fullerenes are also called buckyballs. Here standard enthalpy of formation graphite is thermodynamically more stable allotrope of carbon, and therefore standard enthalpy of formation of graphite is taken as 0. Diamond and fullerenes are less stable due to positive standard enthalpy of formation values. Here diamond has positive value 1.90 kilojoules per mole, and fullerene has positive value plus 38.1 kilojoules per mole. So that's why these are less stable. Amorphous forms of elemental carbon like carbon black, coke and charcoal are all impure forms of graphite or fullerenes. Carbon black is obtained by burning hydrocarbons in an limited supply of air. Charcoal and coke are obtained by heating wood or coal respectively at high temperatures in the absence of air. Explain the allotropes of carbon. After watching this video, just explain the allotropes of carbon on your own. Thanks.